Okay, so for day one, we focused on finding the missing sides. Day two, we're going to focus on finding the missing angles. So with that being said, we're still going to continue to utilize the Soh Cah Toa that we taught you yesterday. So that's something you're still going to need to use in order to find the missing angles. Other little terminology. Sometimes when we're identifying the angle, we use this terminology called theta. And really, if you ever see this symbol in the picture, this is the theta symbol. All that really means is it's just representing the angle that we're trying to find. So it's kind of like a variable in some ways. Instead of them putting X in there or another letter, they use sometimes theta in this case. Now, the first thing we're going to do is we're going to do a little bit of calculator practice. So hopefully you brought your calculators again today. If you did not bring your calculator, then please come back and trade your phone in on drawers 1 through 10 back here and get you a calculator. So when we find the missing angle, they're going to give us, or we're going to know what the ratio is. Notice here the ratio is given to us in decimal form. Yesterday we found the ratios in fraction form. It's all the same. It's just a matter of which form it's in, because we could always take the fraction and put it into decimal form just like you're given to here. Now, the big thing I want you to look at on your calculators that I want you to notice is we have our sine, cosine, and tangent buttons, which those are buttons we talked about yesterday. You should notice above each of those buttons, there is a sine to the -1, a cosine to the -1, and a tangent to the -1. Those are kind of our inverse sine, cosine, and tangent buttons. That is what we're going to use to find the angles if we're given the ratio. So I'm going to do the first two with you, and then you're going to do the last one here on your own before we move on to an actual picture problem. In this first one, to find the angle, basically to get x by itself, what I'm going to do is I am going to do the inverse cosine of the ratio given. So we're using the inverses to find the angles. We're using the regular buttons to find the sides like we did yesterday. So if I'm typing this into my calculator, here's how I do that. So on the calculator that you see here that I've got on the screen, I'm going to hit the second function button, which is that blue button in the upper left corner, and then I'm going to hit cosine. That gives me my inverse cosine on the screen. Then I'm going to type in my ratio, so 0.1234, and then I'm going to hit enter. When I hit enter, that gives me 82.9. So if I'm rounding that to the nearest degree, that would be 83 degrees. So what we just figured out is the cosine, which is equal to this given ratio, tells me that that angle x is 83 degrees. So if I were going to do the second one, on that one, because it's tangent, I'm going to do the inverse tangent of 0.7654. So again, when I'm typing that into my calculator, second function, tangent, 0.7654, and I hit enter. That gives me 37.4, so approximately to the nearest degree, 37 degrees. Okay, so what I want you to try now is go ahead right now, and I want you to see if you can do the last one there, the sine, see if you can find the missing angle. So take a minute, use your calculator, and see if you can do that. Okay, so let's go ahead and go through this third one, see how you did. You should be doing the inverse sine of 0.8653, which when I put that into my calculator, second function sine, 0.8653. and you should get approximately 60 degrees if you're rounding to the nearest degree. Let's take a look at an example here where we're finding the missing angle. So here's what the problems are going to look like for this. Notice in the picture they're giving us two of the sides and they want us to find the missing angle in this case, which is theta. So with relation to theta, you'll notice that we have the adjacent side and the opposite side. So if I go to my Soh Cah Toa, what does that tell me I'm going to use? Tangent. So I'm going to say the tangent of theta is equal to 8 over 5, the opposite over the adjacent. Now, just like we just did on the previous slide, to find theta, which is the angle, I'm going to do the inverse tangent of 8 over 5. Now, the only difference in what we just did on the previous slide is now the ratio is given to us in fraction form, which you can still type that in on your calculator the same way. You're going to do the second function, tangent, 8 divided by 5, parentheses, and then we're going to hit enter. And that tells us that theta in this case, again rounded to the nearest degree, is 58 degrees. Let's take a look at the second one here. Again, we're finding the missing angle. This one they're giving us the bottom side is 12. The hypotenuse is 17. So with relation to our angle there, we have the adjacent side and the hypotenuse. Can somebody tell us what our setup would be for this one? So we go back to our saying, Soh Cah Toa, which one has the A and the H? Yeah, the cosine. So we're going to do the cosine of theta is equal to the adjacent side, which is 12, over the hypotenuse, which is 17. Go ahead right now and see if you can utilize your calculator to find the missing angle based on the setup. Okay, so hopefully you typed into your calculator the inverse cosine. So we type in second function cosine, and we're going to do 12 divided by 17. And hopefully you got for theta here 45 degrees. Show of hands, how many of you got 45? Okay, so this last problem we're going to do today together, they're giving us a triangle, and this one they're wanting us to find all the missing parts. So in this one we're finding the angle A, the length of side B, and the length of side C. So I'm going to give you a few minutes right now, see if you can work through that, and then we'll kind of talk about the process on how we solve that here in just a second. Okay, so guys, I'm going to go ahead and take you through this. There's probably a lot of different ways here that you could go about solving this problem. I'm going to just go ahead and start with the angle because that's probably the easiest thing to find. Notice in this problem they give us the right angle. They give us this is 25. If I want to find angle A, what does angle A and B have to add up to? Has to add up to 90. So if I take 90 minus this 25, that's going to tell me that angle A is 65 degrees. So I don't even have to use trigonometry to find the missing angle here. All right. Now, okay, so the next thing we're going to do is we're going to find one of the missing sides. So if I use my 25 and I find, let's say I'm trying to find angle B or side B, I know that B is the opposite, 8 is the adjacent. So if I do the tangent of 25, that equals B over 8. So this is one where when I type it into my calculator, all I have to do is the tangent of 25 times 8. So tangent 25, and then multiply that times 8. So the length of B here is going to be, if I'm rounding to the nearest tenth, is going to be 3.7. Now I still have to find the length of C. That's my hypotenuse. So if I use my 8 and the C value, now that's going to be cosine, because that's the adjacent and the hypotenuse. So cosine of 25 equals 8 over C. Now to find C, I have to take, basically I'm going to do 8 divided by the cosine of 25 to find that. So when I type that into my calculator, 8 divided by the cosine of 25, and that gets me approximately 8.8 for my hypotenuse. Now, the thing I want to point out to you is these are not the only ways that you could find these values. Could I have used my 65-degree angle with the sides? Yes, I could have. So I'll pick one of those just to kind of show you what I'm talking about. If I use 65 to find B, I could have done the tangent of 65 equals 8 over B, which is opposite over adjacent for that angle. And again, my B value, if I type that into my calculator, 8 divided by the tangent of 65, I'm still going to get a B value here of 3.7, which again, you'll notice is exactly the same. So my only point in showing you that is on these problems, there's going to be more than one way to solve them, depending on which angle you pick and which sides that you pick.